Chapter 3, Part 1, Hydrocarbons and Introducing IUPAC Nomenclature. Hydrocarbons is a large overarching term used to describe a considerably large family of compounds. The name hydrocarbons comes from the fact that there is only hydrogen and carbon in these compounds. Now, there are two different families of hydrocarbons. There are saturated hydrocarbons and unsaturated hydrocarbons. These terms should be familiar to you from CHEM when you talked about degrees of unsaturation. Saturation means that the compound is holding all of the hydrogen it possibly could, while unsaturated compounds have lost some hydrogen in the form of multiple bonds. So our only compounds in the saturated family are alkanes, A-L-K-A-N-E-S. Alkanes are covered in Chapter 3, which is this chapter, and alkanes contain only carbon-carbon single bonds. There are no double bonds, triple bonds, and there are also no rings, technically, in an alkane. An alkane can look like something as simple as H3C, CH3. So there is a single bond between the two carbons, and there are 3 hydrogens on each of the carbons. The name of this compound is ethane. We'll talk about where all these pieces come from later, but the basic idea is there is a prefix that indicates how many carbons are present in the molecule. Eth happens to be the prefix that indicates that there are 2 carbons. The infix, An, tells us that there are only carbon-carbon single bonds, and the suffix E tells us this is a hydrocarbon. You'll see how the name changes as we look at different families of compounds. Our next group are the alkenes. Alkenes are part of the unsaturated family. These are covered in chapters 4 and 5. Alkenes must have at least one carbon-carbon double bond. This could look like H2C with a double bond to the next carbon and 2 more hydrogens. Notice that in our alkane, which is saturated, there are 3 hydrogens on each carbon, which is the maximum in this situation. Whereas in the alkene, which also only has 2 carbons, there are only 2 hydrogens on each carbon. The name of this compound is ethene. So notice that the prefix and the suffix have stayed the same, but the infix has changed to reflect the presence of carbon-carbon double bonds. Our next family are alkynes. Alkynes are also covered in chapters 4 and 5, and for something to be considered an alkyne, it must have at least one carbon-carbon triple bond. Oops, there's a typo there, I will fix that. The triple bond is between the 2 carbons, and notice we have lost a hydrogen on each of these carbons again. The name of this compound is ethyne. So we're keeping our prefix, keeping our suffix, but the infix has changed to denote the change in the nature of the carbon-carbon bonds. Let's do an unofficial edit here. Triple. The next family of compounds are arenes. Arenes do not fit the same patterns here. We do not cover them until chapter 9 because their chemistry is pretty different. And an arene has at least one benzene-like ring. The nomenclature of arenes is more complicated, so we're not going to try to indicate it here. Now the next thing we need to talk about is IUPAC nomenclature. IUPAC stands for the International Union of Pure and Applied Chemistry. This is a system of nomenclature that is used worldwide. It uses a clearly defined set of rules with prefixes, infixes, and suffixes. We're going to look at the prefixes first. So the prefixes tell us how many carbons are present in the compound. So if you have 1 carbon present in the compound, you use the prefix meth. 2 carbons is eth, 3 is prop, 4 is bute, 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. If I were you, I would make flashcards for these because you do need to know them. And I also want to be clear that the prefix does not include an A or a Y or anything like that, right? So it ends right after this. Now, we also have something called a substituent, and we haven't defined this word yet, but you will see sometimes that these prefixes are used again with a YL. Anytime you see a YL ending in the IUPAC system, it's indicating that you're talking about a smaller piece of the molecule. So this would be a piece of the molecule that is coming off of something that's either bigger or more important due to the presence of a functional group. So when we have a decoration on a molecule that is 1 carbon long, we call it methyl. If we have a 2 carbon decoration, we call it ethyl. So YL means that you're describing a smaller piece of the molecule. Now, when we're naming alkanes, there are kind of 2 different processes here. For an unbranched alkane, meaning just a simple chain of carbons and hydrogens, the process is really simple. You use the prefix, which is the number of carbons, followed by the infix, which tells you the nature of the carbon-carbon bonds. So if it's all single bonds, your infix is AN. If you have 1 or more double bonds, your infix is EN. 1 or more triple bonds, your infix is YN. The suffix tells you the functional group. E is the suffix for hydrocarbons. For branched alkanes, this means that you have an alkane that has an unbranched alkane as a base, and then it has some sort of decoration. You're going to use the parent name, which is the longest unbranched chain. And then you also need to add on the names of the substituents and a locant, which tells you the number of the carbon where the substituent lives. So an example of an unbranched alkane would be something like this. This alkane has 5 carbons, and the prefix for 5 is pent. There are only carbon-carbon single bonds, so I'm going to use the infix AN, and this is a hydrocarbon, so my suffix is E. The branched alkanes actually is a different slideshow. We're going to get to that next, so I'm going to skip this for now. Now, before we get into all of the official rules of IUPAC nomenclature, there are some words that we need to define just so we can have a clearer conversation. The first part is parent chain or compound. This always references the longest continuous carbon chain. A substituent is a smaller or less important group coming off of the parent chain. I will often refer to it as a decoration to help you remember that it's just coming off of something more important. The locant is a number used to indicate where a substituent is located on the parent chain. This is the so-called address of the substituent.